Okay, hopefully after watching the previous video, you've got an idea what's going on with these, but I'll rattle through it. Okay, so we want to divide 3x cubed plus 6x squared minus 4x plus 10 by this bracket, which means we want to say, what can I multiply that bracket by in order to get this answer? Okay, because I don't expect it to be exact, I expect there to be a remainder, so there's going to be something here as well. And in order to set that up, we need the grid, and down the side of the grid I need this 3x minus 2, and I need to figure out what goes on the top of along the top of the grid. The difference between this and the previous one is I've now got a number in front of the x's, but the process is the same. So I need to make this 3x cubed term. Okay, I'll put it in my grid, it's going to appear. How do I make it appear? I need an x squared to multiply the 3x by to make this, and when I multiply this together I'm going to have a minus 2x squared down here. Now the other x squared term is going to be there. So what do I need to appear here so I end up with 6x squared overall? Well, the answer is minus 2x squared plus 8x squared is going to give me plus 6x squared. Okay, so how do I make an 8x squared by doing 3x times something? Well, it's going to be 3x times, it's going to have a fraction in it. It's going to have to be 8/3 of an x. And if I do minus 2 times 8/3 of an x, then I'm going to down here get minus 16/3 of an x. And overall I need minus 4x. Okay, so how many x's do I need to combine with my minus 16/3 x? Well, minus 16/3 is minus 5 1/3, isn't it? So I need to add 4/3 of an x. Okay, minus 16/3 plus 4/3 is minus 12/3, and minus 12/3 is 4x, which is what I want. What do I need to multiply 3x by to get 4/3 of x? It must be 4/9. And minus 2 times 4/9 is minus 8/9. Yes, it is. And so that is the end of the table proper. But if I think about creating my 10, so I've made this happen, I've made this happen. If I think about my 10, I need to have plus 10 and 8/9. So I could say 10 and 8/9. Or another way of saying the same thing, that's 98/9, isn't it? Okay, so this can happen sometimes when you've got a number in front of the x. Okay, you do get horrible fractions, like we have here. Sometimes it works out beautifully though. All right, so in this bracket here, we're going to have the x squared plus the 8/3 x plus the 4/9, and as our remainder we need plus 98/9. So that's one way of expressing the answer, or I can talk about the quotient and the remainder. The quotient is the x squared plus 8/3 x plus 4/9, and the remainder is 98/9. Okay, or I can write it in the fractional version. So probably the commonest way you'll have to use this is to say that the 3x squared plus 6x squared minus 4x plus 10, when we divide by the 3x minus 2, then the quotient part is just the cubit. So that is the bit that comes out as a pure polynomial, and then the bit that has to be left as a fraction is plus 98/9 divided by 3x minus 2. And I'm done. Okay, we've got a couple more to do. This next one's a whole lot friendlier, but it's got this one here. It's got some terms missing. It just looks like an x squared, but it just means that when I set up my grid, I've got to, maybe deal with some things that are 0, but I mustn't miss out any terms in the grid. What I mean by that is we need to make x squared as the thing I'm dividing by, x plus 1 times another bracket, and then we've got a remainder after that probably as well. So, all right. So my grid looks like x plus 1 down the side. Okay, I need to create an x squared, and the only way I can create an x squared is by doing an x times an x. Okay, all right. So that creates an x down here whether I want it or not. Now you don't see any x's in this, so that means I require 0x. So when there's a gap, when the term just isn't mentioned, you still have to consider it. It's just that you need to make sure that you get a total of 0. So I need a minus x here. Okay, in order to get a minus x, I'm going to need a minus 1. When I multiply that by the 1 down here, I'm going to get a minus 1. That's the end of my grid proper, because I've got down to a constant. But the constant term here, well, again, there isn't one, it's 0. but I've got a minus 1, so I have to consider that as well. How do I get a total of 0? I need to have minus 1 plus 1. So my remainder at the end is plus 1, and the contents of the bracket is this bracket here, which is x minus 1 plus 1. This clearly works, because x plus 1 times x minus 1 is x squared minus 1, and adding this 1 gives me x squared. So the quotient is the x minus 1, the remainder is the plus 1 at the end, and I can say that x squared divided by x plus 1 equals x minus 1 plus 1 over x plus 1. So here's my quotient, and here's my remainder. Okay? Alright, you've probably got one more on your page, which is, it's 4x divided by 2x plus 1. So for this one here, you're going to need to say that 4x is going to equal 2x plus 1 in a bracket times something else, okay, and a remainder, okay. Now this one is a bit sort of unusual because these have got the same highest power of x, so it just means I'm just going to have a constant. It's just a very short process, but I can still set up the grid. It's just I need to be not surprised when I run out of grid very quickly. So I've got 2x plus 1 down the side, and I need to make this 4x. So I need to make 4x there. How am I going to do that? Well, it's got to be 2x times 2. And 2 times 1 gives me 2 down here whether I want it or not. Okay, and I've run out of grid, but I still have to consider the remainder. So these two terms here, okay, have to give me, I've got a 0. So just as in the previous one, I need to make a minus 2 here. That will give me a total of 0. So my remainder is minus 2. And my quotient, the thing in this bracket, is just 2. Okay, so you can just end up with a constant. If you use the leading term rule, the first term here, 4x, divided by the first term here, 2x, 4x divided by 2x is 2. So I'm expecting a quotient of 2. So my quotient is 2, my remainder is minus 1, and in the fraction form, this is what you're most likely to have to do, 2x plus 1 on the bottom. So the non-fractional bit of the answer is just a quotient, which is my 2, and the fractional bit of the answer is the minus 2, the remainder, which still has to be divided by the 2x plus 1. So for completeness, you've got a variety of different versions of that. Hope that helps.